Teknologi 10 November is one of the best university in Indonesia based on Kemristek-Dikti. ITS prioritize education, research and innovation which has high quality. In 2023, ITS releases the International Undergraduate Program of Statistics called the IUP of Statistics for Indonesian and international students, where English as the intermediate language in learning.
Random. So it means that Sambal Random has two.
While studying, the IUP students will get international exposure such as students exchange, international internships, international short-term academic, have an opportunity for double degree in ITS and abroad university only 4 years. Also, get national and international certification. In IUP of Statistics, the students educated by competent lecturers, also supported by complete facility. There are 5 statistics laboratories, includes Laboratory of Computational Statistics and Data Science, Laboratory of Business and Industrial Statistics, Laboratory of Social Statistics and Population Studies, Laboratory of Health and Environmental Statistics, and Laboratory of Economics and Financial Data Analytics. Representative Classroom, Statistic Corner, Cool Sigma Garden, Musola, and toilets. Beside academic support, the students also supported to develop themselves through students' organization and sports activity.
Hi all, my name is Adina Rama. I'm from Statistics IUP Batch 2020. I would like to share a little bit of my experience of studying abroad to Canada under Canada Asian Seed Scholarship and UMAP Special Scholarship. Along the semester, I definitely feel a couple of hard times, and I am very thankful for International Office from ITS. They really guided me and were very helpful. They made my experience even more amazing. I definitely made a couple of friends there that I wouldn't have made if I stayed in Indonesia. Lastly, I hope that a little bit of my experience would be one of the reasons for you guys to choose Statistics IUP.
In now era, English is not skill, but necessary even though the requirement. So, join in IUP of Statistics is the best choice for preparing ourselves to compete in global level. International Undergraduate Program of Statistics, ITS.
Good afternoon, ladies and gentlemen. Honorable Speaker Professor Jasni Muhammad Zain from Institute of Big Data Analytics and Artificial Intelligence in University Teknologi Mara, Malaysia. Our respectable Prof. Hamzah Fansuri, Dean of Faculty of Scientifics, ITS. Good morning, good afternoon. And Bu Kartika Fitriasari, as a head of Department of Statistics, ITS. Also, for all the students and participants of this international guest lecture, we are delighted to welcome you to the international guest lecture today, entitled by Data Mining for Healthcare and Oil and Gas Industry by Department of Statistics, Faculty of Scientifics, ITS. First and foremost, I would like to express my gratitude to God apart from any circumstances that we are facing today. We are all happy, healthy, and ready to participate in this guest lecture. Let me introduce myself first. My name is Dwi Ari, and I will hold the role as the host and moderator of the international guest lecture today. This event is running via Zoom and YouTube live session. So for all the participants in Zoom, please turn your microphone off to reduce the noise. And please feel free to use our virtual background that will be sent by the team via the chat box in Zoom for today's lecture. And we want to inform you that the link for the attendance and to claim the certificate would be shared by the team through the Zoom or YouTube chat box during the lecture. Okay, so please stay tuned and kindly wait for it. And I would like to inform you that the rundown of this CAT lecture will be started by the opening, followed by the speech from Professor Hamzah Fansuri. And then afterwards would be the photo session. Then the following session would be the lecture by Professor Jasni. And lastly, we would like to have a discussion after the lecture about the material of the lecture today. Without waiting any longer, let's start the session by hearing the welcoming speech from Professor Hamzah Fansuri as a Dean of Faculty of Scientifics, IPS. Please, Professor Hamzah, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, the Honorable Dr. Jasni Jain, our guest speaker this afternoon. Selamat siang, Dr. Jasni. Yeah, the Jasni is from Malaysia, yeah. UISM. Is it correct? Yeah. The Honorable Dr. Kartika Fitriasari, the Department Head of Statistics, and our lecturer, professors, ITS, and also all attendants of this webinar. This afternoon is very special for all of us here because we have this tamu jauh, yeah, from Malaysia with us. We will give a talk, a lecture, yeah. What's it about? Yeah, hold on. For this afternoon talks, sorry, I cannot pick up the themes of this webinar, but I'm very sure it will be very useful for all of us here. And as the Dean for Faculty of Science and Data Analytics, as well as representative of ITS, I would like to say our gratitude for the ability of Dr. Jasni to give the lecture this afternoon. For all the participants, I'm hoping that this event, this webinar, will open wide our knowledge, our experience in the field that will be discussed and presented and discussed this afternoon. And I'm hoping that all of you can maximize this opportunity to get the information. Yeah. Of course, we're also hoping that this occasion is not the one and the first ones and finish, but this is only the beginning of our fruitful collaborations between ITS and UISM. Yeah. And I was informed by Dr. Kartika that in September we will sign the agreement, and I will try to find my best way to also visit UISM. Yeah, just for the information that I will have a conference in Johor Bahru just 1 week before the conference in UISM. I'm hoping that I will be given opportunity and also permission from rector to visit Malaysia in consecutive weeks. Yeah. I don't want to use more times. It's already 8 minutes past the scheduled times. And in this session, it's Bismillahirrahmanirrahim. I'm officially open this guest lecture. Thank you very much and enjoy this guest lecture from Dr. Jasmine Zain. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Hamzah, for the enlightening speech. Professor Hamzah, it would be great if you could stay with us, but if you need to be somewhere else, we understand. Thank you very much, Prof. Hamzah.
Yeah, I'll be around about 10 to 15 minutes. Yeah.
Okay. Yeah. Thank you.
Thank you, Prof.
Okay, now, now before the main session, we are going to have a photo session first. So please feel free for the participants to use our virtual background that has been shared in Zoom in the chat box. And if you are ready, please turn on your camera and give your very best smile for the photo. And I will guide for the photo taking session. I will count from 3 to 1 for taking the photo. Okay, let's see. Here we have about 6 pages. Let's start from the page 1. I will count from 3, 2, 1. Okay, start again for the page 1. I will count for 3, 2, 1. Okay, let's move to the page 2. 3, 2, 1. Okay, page 3, 3, 2, 1. Okay, page 4, 3, 2, 1. 5, 3, 2, 1. Okay, I think that's all. We just have 5 pages. Thank you. And for all participants, we want to remind you that the link for the attendance will be shared by the committee during the lecture later. Okay, now let's move on to the next session. Before we listen to the lecture, let me briefly introduce our speaker today. Professor Jasni Muhammad Zain is a professor in Institute of Big Data Analytics and Artificial Intelligence in University Technology Mara, Malaysia. She got her bachelor's degree in computer science from University of Liverpool in UK, and then she got her postgraduate certificate from mathematics at Sheffield Hallam University in UK, and she continued to master degree in Hull University in UK, and she received her PhD degree from Brunel University in West London, UK. And her areas of expertise are digital watermarking, image processing, data security, and data mining. And for all the participants, if you have any questions for the lecture later, please drop your question in the chat box. And also, if you want to ask directly to the speakers or Professor Jasni, you can use the raise hand facility during the discussion session after the presentation. Okay, without further ado, I want to welcome Professor Jasni for the presentation. Professor Jasni, the time is yours.
Thank you very much, Dr. Diari. Let me share my screen first. Is that okay now? You can see my screen now?
Yes, Professor.
Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Professor Dr. Hamzah Fansuri, the Dean for Faculty of Science and Data Analytics, ITS. Dr. Kartika Fitriasari, the Head of Department Statistics, ITS. All professors, lecturers, and all participants for the guest lecture today. Once again, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for inviting me to give this lecture today. I am very honored to be here to share some of my experience in some of the projects that I have done in the past few years. Hopefully, this will give some insights to all of you participants here today. Just a little bit of background of my institute. So the institute is the Institute for Big Data Analytics and Artificial Intelligence, short form IBDAI. So at the moment we have 7 fellows, including me. So myself, under the digital watermarking, image processing, and data mining, data security. We have Prof. Dr. Haja Azlina Haji Muhammad. She has just retired, okay, but she's still under being our fellow for this year. Her expertise is on AI, big data analytics, decision support system. The next one is Prof. Yap Diwa. I'm sure some of you have known Prof. Yap, Prof. Azlina from our friendship and also co-organizing the conferences from the ITM and ITS from the past, I think, 7-8 years now with SCDS. Thank you very much. So Prof. Yap has also retired. She's in another university now, but still under our associate fellow. So her expertise is on predictive analytics, computational statistics, multivariate data analysis. I'm so sorry, I still have cough. It's been few months now, but it's still bothering me. So please excuse me if I have cough once in a while. So also Professor Madya, Dr. Marina Yusuf, her expertise in AI, machine learning, deep learning, data analytics, swarm intelligence, multidisciplinary research. We have Professor Madya Dr. Muriza Kasim, her expertise on network management, IoT, mobile and web applications. The next one is Professor Madya Dr. Azlan Ismail. His expertise is on self-adaptive systems, cloud computing, and software synthesis. The last one is Dr. Saiful Farid Matyati. His expertise is on digitization, information management, knowledge management, records, and archive management. So that's it about our institute. We are being upgraded to Center of Excellence for the last 2.5 years now. So hopefully we will become a Malaysian high COE in the next 3 years, inshallah. Okay, so we start with a an ayah from the Quran, from chapter 6, verses 59. وعنده مفاتيح الغيب لا يعلمها إلا هو ويعلم ما في البر والبحر وما تسقط من ورقة إلا يعلمها ولا حبة في ظلمات الأرض ولا رطب ولا يابس إلا في كتاب مبين. So the translation of the ayah is, and with him are the keys of the unseen. None knows them except him. And he knows what is on the land and in the sea. Not a leaf falls, but that he knows it. And no grain is there within the darknesses of the earth, and no moist or dry thing, but that it is written in a clear record. So why I'm putting this ayah to open my talk today is because we are going to talk about data or big data in our case. And now we are crunching or analyzing a lot of data that we do not know how to, what to say with the data. We don't know the story. We want to analyze that. We want to know everything. What happened? Okay, that Allah has said 1,400 years, more than 1,400 years ago, that He knows everything. That He even says that not a leaf falls, that He knows it. So just imagine now with all the technologies that we have, we are trying, as if we want to count how many leaves that falls. And Allah has written it clear in here that He is the one who knows it without having to calculate, without having to have to collect the data. It's all in a clear record. So just to have this in mind, that we are not far. I mean, our knowledge is so far from what Allah has said, that what He is capable of. So we are trying to learn from that. But at the same time, we remember that there is God there that knows everything. Okay, so what I will be talking for the next maybe half an hour to 1 hour after this. I thought I'm going to finish in 45 minutes, I said to Dr. Santi, but we will see. So the topic given to me is data mining. So I cannot start the talk without explaining what is data, or in my case, now that we are talking about big data. So what is big data? So what are the skills required? Big data framework, what are the tools? What are the applications? And because this is a specific application that given to me, she said, okay, I talk about healthcare and oil and gas because we have some projects that we have done, finished and ongoing on these two areas. Okay. So talking about big data. So now we in the past, I mean, few years we are talking. People are, talking about big data and saying that data is the new oil and the currency for the future. So we are seeing that data has the value. Data has the value. It is not free, and it is you just don't give your data freely to anyone. So if anyone asks for your data, you you don't easily go and advertise it to anyone nowadays, nowadays. So because what people can do with your information, your data is, there's so much, there's so many researchers going on out there, looking at our data, crunching them and make it into a very, very good information for some of the businesses going out there. Okay, so in terms of data science, okay, it is a multidisciplinary field, okay, for data mining or data science. It has to be include mathematics, statistics, and also computer science. So we are in the right combination. I think you are from the Department of Statistics. I'm from the computer science, and the faculty is Faculty of Science and Data Analytics. So meaning under your faculty, there must be all these combinations that that will enable for you to crunch all this data and make sure it will be useful in the future, or useful for you and those who want to use it. Okay, so talking about big data, there are characteristics of those data. So we used to have 3 V's, and then we go to 6 V's, and then now there are 7 V's. Okay? We start with volume, variety, velocity, variability, value, veracity. So we will go on. Okay, the last one, the latest V is the visualization. Since people want, the management wants to look at the results of the data, what decision they want to make. They want to make quick decisions, so they want to visualize all this data, what this data means to them and to the business. You know, what are the things that they want to, for example, invest? How are they going to invest? Where they are going to invest their, you know, money for more profit, example. So we will go through all these one by one. So volume, when you talk about volume, we will ask how big data is. So as the times, the technology grows, okay, so we can store more and more data. Okay, now we are talking about yottabytes to describe how much government data the NSA or FBI have on people. So US may have the most or the biggest data that is available today. Maybe they have all our data, okay, all together. We all use, you know, Google, if you ask, right? And then in the near future, we are going to Brontobyte, the 10 to the 27. So it will be the measurement to describe the type of sensor data that will be generated from the IoT. So disebabkan we have, you know, these sensors coming in, sensors collecting all sorts of data. So the data will be so huge. And how do you store them? You see how it has evolved from the last time that we had the first computer that had only kilobytes, okay, and then you have your handphones, 128 gig. Now you have more than this. You have maybe 1 terabyte. okay, and then laptops and so on to the US NSA data center. Then when you go to the variety of data, you look at how many types, how many data types are there? Are they structured? Are they unstructured data? So you will see different data types that's coming in, not just if you go, like, for example, okay, you go for the date, okay, date, later on you will see that different vendors use different format for dates, and you have to make sure all these dates goes on the same format and so on. So not talking about how to clean the data yet, just look at all these different types of data. Those are variety. And then the velocity of the data. Nowadays, we have very high velocity of data that comes from real-time system, also we, if we just compare, for example, banking, okay, in those days, maybe 20 years ago or 30 years ago, we have to line up at the bank to do transactions, right? We have to fill in forms, to put in money or to draw money from the bank. Then we have the ATM machines, okay? ATM machines, still you have to go to one place and draw the money. But now you can do all sorts of transactions online, and it does not, stop you if the bank is closed or things like that. You can do transaction any time of the day with the e-commerce that is offering you, you can shop with Shopee, you can use your Grab 24 hours a day. So those transactions come in a high velocity, yeah. And for example, IoT for transport, there you have sensors coming in, and those who collect all this data will have to deal with kind of velocity of the data. And veracity is the accuracy of the data. So it is another dimension, or it can be a problem when you have data that is uncertain or data that is not accurate. You can have inaccurate data, because if you have a poor data quality, it will cost your company a lot of money to just verify the data and so on. So if you look at the statistics here, it says poor data quality costs the US economy around 3.1 trillion a year. Okay, so we need tools and analytics to manage and mine the imprecise or uncertain data. And also it says that 1 in 3 business leaders don't trust the information they use to make decisions. So there are some uncertainty, or, they're not trusting. I'm not trusting all my data. It just says that. And in a survey, 27% of respondents, they were unsure of how much of their data was inaccurate. So That's what veracity means. Okay, then we go on to the variability. So variability is, example, you have the same word but means different thing. Okay, so for example, the word nice. Okay, nice in one sentence it is a good thing, but in another sentence it is not a good thing. Okay, when you say that's not a nice thing to say, so these refer to some other thing. Okay. Also, okay, for why you have variability, because when you mine for data from social media, for example, tweets. Okay, people who do sentiment analysis, so they want to look at the sentiment, positive or negative. So just looking at the word only might not be sufficient. Okay, so you have to look at the context of the word in a sentence. Okay, so another example here is grade. Okay, so one is a positive grade and another one is a negative grade. Okay, so you have okay, delicious muesli from Imagery Cafe. What a great day, a great way to start my day. So the grade here is a positive sentiment, and another one had to wait in line 45 minutes at the Imaginary Cafe. Great. Well, that's my lunch break gone. So great here means a negative connotation, negative meaning. Okay, so that's variability. And then value. So what is the value? Is data has a value? Is data, big data equals data and value? So what we define, it says here from Oracle, it says 4 characteristics defined by Oracle. What makes big data is, number 1 is volume, velocity, and variety, and also the value. So value is the potential of a business to harness the high value of that data. So extracting the true value and unlocking the true value of your big data, it will take a lot of computing power, and for this you need a supercomputing infrastructure. So that's what Oracle says about value. Okay, and the sorry about that. So last V is the visualization. So we have all the data information source, and you want to present the data in a manner that is readable and accessible, and finding a way to present this information that makes the finding clear. And you have to think, okay, now what tool can help me to visualize all this data, right? So you can visualize data using R, for example. So you have the scatter plots, box plot. You can use Python. Also can have box plot, and you can have also this multiple distribution using Python. Okay, so for the students, okay, in terms of data mining, or what we can do, or what the industry are looking for in, for example, they have this many posts now. There's many different jobs for data. This is data engineer, data analyst, data professional, data scientist, and all these requires the same skill sets, I think. Okay, so if you have R or Python, yeah, you have used the tools, the Tableau or Power BI, or you can have Cloudera or Hadoop, and also other data analytics skills. So that will be good for you to work as a data engineer, data analyst, or data professional scientist. And the modern data scientist, so what you need from your program are combinations of all these, okay, all this domain. From math and statistics, you have machine learning. So maybe, part of data mining will be machine learning, statistical modeling, and so on. Okay, you have programming and database, soft skills, and also communication and visualization. So you look at these two technicals and two soft skills that you need to combine them to be a successful data scientist. Why am my slides moving? Okay, then I'm just going to discuss a little bit about what we do. So we have at the institute that we have this big data framework. So we are looking at all the processes from left to right is the policy and data access. Okay, so it is very important to have, for example, for an organization or the government, you need to have policy on data and data access. And then you have all these data source is from the bottom to the top is on the applications. Okay, so you have data source from the cloud, from media, social, from industry, from transportation, finance, from all over the industry to go into the technology platform that what you need to do for data ingestion, processing, and storage. Okay, when you talk about collecting all this data, then it is very, very important for you to think about how do you store them? What are the policy for this data? How long do we keep data in our storage, or and what are the these are some of the technology that we can use for all these. Okay, so for data ingestion, there are Kafka, Plume, Storm, and for data processing, there's for ETL and integration, we have Talent, Spark. Storage, yeah, Couchbase, Hadoop, Sandra. Okay, then go up to data analytics. You have data processing that you can have descriptive analytics. You can have predictive analytics, prescriptive, and also you can tell the story. You do the storytelling with the data. Okay, so you have you can do statistical analysis for descriptive analytics. For predictive, you have data mining, machine learning. For prescriptive and storytelling, you can use SAS, R, SPSS, Python, and also Microsoft Azure. And for the decision making and visualization, you can use Tableau, Power BI, and also Pentaho. Okay, so those are the framework, and on the right side you see the security. Okay, so we have to design all this with the security of the data in mind. Okay, so just remember when you do all this, you have to be aware of what is going on when you collect data. Is it what are the policy? You know, you need to ask anybody for it. Is there a form that you have to fill in? Is there an ethical issues on the data, or how you going to use it? You know, there are different department or different agencies who have to look at what you collect or what you are doing with all the data. So that's why there are, you know, litigation cases. There are of data usage, especially with, you know, Facebooks. You know, they have all court cases that have used our data for, you know, without consent or without we know what they use our data for. Okay. All right. So danger in data. So garbage in, garbage out. So if you have, you know, make sure whatever you want, you have whatever you want to do, you have the right data and you get the right model to make the right decisions. So if you don't have the right data, then you may make the wrong decision. Okay. So we have the data science processes. So it can be a little bit the same with the data framework just now. So I will skip that one. And then you have the data analytics. Okay, the processes, descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So for descriptive analytics, basically we report the summary statistics, okay, to say what happened, okay, what happened, what you do with your data. Based on your data, what is happening there, okay. So for diagnostic analytics, you want to know more insights from your data. You want to know why something happens, why did it happen. And for predictive, you know what will happen after you have all your data, you crunch it, you want to know what will happen next. You can predict not the future. You can say what will be happening after that. After you see the patterns of what happens before. So to evaluate you know, several prediction models, you can use many models for this. And for prescriptive analytics, how you make it happen. So you can recommend the best prediction model. You can say, oh, this failure will happen here. So you can recommend that they change or do something before the failure happens. So they will not face the consequence, or it will cost them a lot more when the failure happens. Then you mitigate the failure earlier before it happens. Okay. So Descriptive for data discovery and exploration, you can do descriptive by doing this box plot and do the exploratory by looking at relationship, looking at the clusters of things. You can, cluster them into different groups and you can see the trends. And for predictive analytics, from the machine learning perspective, you can use Weka SAS R. This is the first, second, and third generation. What you can do with them? Okay, they can have deep analytics with large collection of serial machine learning algorithm. They have vertical scaling, scalability, and also single fault tolerance. For the second generation, with the RapidMiner, Mahout, and also Pentaho, you can work over Hadoop MapReduce, shallow analytics on big data, but small number of machine learning algorithms. And going on to the third generation, you have the Apache Storm and Spark, Halu, Giraffe, Pigel, and Storm. You have deep analytics on the big data, and you can realize the machine learning algorithm in real time using Kafka, Storm, and integrated environment. Okay, so for the right decision and acquiring significance for prescriptive analysis, storytelling, and visualization, you see, you have the narrative, the visual, you have the data, and you can explain, okay, using the narrative, and you can enlighten using visuals. And the narrative and visuals will engage your audience. Okay, so using the right tools for the right decision, so you can use what visualization and what are the dashboard that you want to use. You can choose either using Oracle, Power BI, or Tableau, or Microsoft. Okay, so these are the RapidMiner and also the data mining software that you can use. IBM SPSS Modeler and also SAS. Okay. Now, so going to, okay, baru nak cakap pasal data mining. So what do you do? Okay, for data mining, what do you do? What is it that you do to mine the data? You want to look at the process and you want to discover insights from the large database that you have. Okay, so there's a standard for this. So you have CRISP-DM, so cross-industry standard process for data mining. And this is a standard framework developed to help carry out data mining project. And this was developed by a consortium of companies, mainly in the Europe. And there are 6 phases of steps for CRISP data mining. So number 1 is the business understanding, data understanding, data prep, modeling, evaluation, and also deployment. And after that, you can monitor the data and can go back to your model again, and you can re-evaluate and push one. Okay, so where you can get your data from? Okay, there are all sorts of data that you can work on. Okay, from the social media to credit cards, rainfall, airlines, medical data, this enterprise data such as Amazon and so on. Okay, so what you can do, what analytics you can do. You can predict. You can do predictive analytics. You can do customer analytics, sentiment analytics, and also market basket analysis. So, for example, with Amazon.com and so on. So, like Maybank to you, or the banks can do customer or market basket analysis. Okay, so for what did I do? So for data mining process, okay. So first, number one is you have to identify what problem and what are the goal of your data mining. Okay. Apa masalah dia kan? What is it that you want to find out from the data that you have? Okay. Number two is for you to understand the data. So from the goal, then you can select variables that is known or suitable for your problem. And then you will do the data preparation, which is data integration, data cleaning, data imputation, and so on. So looking at them, then you will do the next step, which is the data mining, going to predictive modeling, segmentation analysis, association analysis, and then evaluate the results, and you can deploy your model. Okay, so we have give you examples here. For predictive analytics, that is focused on classification and prediction of a target variable. For example, if you have, classification of credit risk. So you can have good risk versus bad risk. So this is like a binary classification, right? Okay. For example, classification of survival after surgery. So you have survive versus did not survive. So how many survive? How many did not survive? Who classifies as all these two targets? Okay. For example, signatures. You want to know whether it's genuine or forged. Okay. And also classification of images. You want to know whether it is real or fake. So you have these classification of variables. And the next example is, for example, the credit risk. So you have the high risk and low risk, and you see, okay, so this is savings against income. So the more income you have and the more savings you have, you are a low risk. So you can have a good credit scoring, and you'll be given loan or whatever you want to take credit. Okay. Classification of low risk and high risk customers based on income, and if you base on income and savings. So this how you do, for example, okay, predictive modeling or known as supervised classification. So you have cases and you have, like, for example, the inputs are age, income, savings, loans. So you have this binary targets. So high risk and low risk. So these are the some of the examples. So for machine learning algorithms, you have loads of algorithms that you can choose on. Okay, from deep learning. Now we have deep learning, ensemble learning, neural networks, regularization, rule system, regression. Regression is the maybe people say this the most easiest one. Maybe not. Maybe yes. Okay, you have clustering, instance-based, dimensionality detection, a decision tree, Bayesian model. So these are some predictive modeling techniques for industry application that you can use. Okay, for example, logistic regression using a statistical model. We have decision tree. This is a machine learning technique. We have support vector machine, SVM. This is machine learning algorithm using kernels for linear and non-linear classification. We also have neural network model, which using AI model, and Bayesian network model. This is a probabilistic model using Bayes theorem, and also fuzzy KNN, fuzzy logic. So you can see, build your model using categorical dependent target variables. For example, this one, you have location, advertisement using how much money you use for advertisement. We have the sales team. These are the predictors. And the outcome is the sales revenue. Okay, whether it is more than 5 million or less than 5 million. So Y dependent variable is categorical.
Prof. Jasmine, I'm sorry for the interruption. The slide in the display, I think it's stuck in one slide. Could you please share your screen?
What do you see now?
Yes, I see, but it's stuck right now in one slide of data mining process.
Oh, okay.
Could you please reshare your screen?
What should I do?
I think you can stop share and then reshare again your screen.
Stop sharing. And then share one more time. I'm so sorry. Okay, what do you see now?
The categorical now is logistic regression model.
Okay. So,
okay, good. Thank you.
We have logistic regression model. So it is using the prediction of churn. For example, Y equals 1 is churn or 0 is active. Okay, so you have the probability for the event, and the binary logistic model is here. Okay, and also you have a decision tree, for example. Okay, this is for job application data. So you have independent variables. For example, you have a degree, what is your major and experience, and also where the state that you are coming from. Okay, the next one is the I don't know what's going on. So this is the artificial neural network model, so ANN. So you have multi-layer perceptron, is MLP, is the most widely used type of neural network. So for example, you have age, income as the input layer here, and then the hidden layer and output layer, and you have the target for the chain correlation. Okay. So for example, you have the age and income just now. You have a combination of the in the hidden layer, and the output layer is the combination of the activation of function to transform the output into a suitable skill for the expected value of the target. Okay, so these are the example you have here. And so you have the combination or the output. So the next one is the SVM. So for SVM, you can perform linear or non-linear classification. So if, for example, if you have linear, you might misclassify some points by linear separation bound. So you use a non-linear separation boundary to make sure all your points are classified, correctly classified. So I'm just going through a very brief introduction for all these. Okay, so this is the SVM. You can have linear polynomial RBF and also CMOI. So going on to the top data applications nowadays that you have from the e-commerce, airline, fast food, agriculture, banking, weather patterns, healthcare, government, education. So the oil and gas must be somewhere here. Maybe okay, so these are the challenges for data today. Okay, number one is the issues in scaling. We talk about the poor data quality, the incorrect integration of data, real-time data, lack of expertise, security and privacy, organizational resistance, data verification, heavy expenses, and also the wide technologies variety. So these are the challenges for deploying the big data. And also that I want to also highlight from the instances that the Cambridge Analytica scandal, that using the Facebook user data, about up to 87 million Facebook users had their data exposed by Facebook, okay, by Cambridge Analytica using political, this is a political consulting firm that work on Trump campaign. So what they did was using all the Facebook users data to post or to see their social inclination. Okay, so they will group. Okay, this group of people will will have more influence on this kind of statement and so on. So, yeah. So what they keep was, the data is used to gain your vote, whether you will, support this political party or not. So how much do political parties know about you and how it is used to try to sway your vote? So that is the question that we need to know and ask ourselves. The Cambridge Analytica scandal has thrown light on how the Facebook data of millions have been harvested and turned into a messaging tool. Okay. So bahaya juga. Harapnya tidak terjadi ya di Indonesia atau di Malaysia. Malaysia nampak gayanya sudah berlaku. It makes social havoc kan, give false news ke ataupun memberi berita-berita yang menyebabkan menimbulkan kemarahan dan sebagainya. Okay, so for example, the last time that we did some project on the COVID-19 pandemic, we have one for because it stopped for two years, right? The people cannot go to Hajj, only a few of them. So the waiting list is becoming longer and longer for Malaysia, especially. I don't know, maybe it is the same with Indonesia. We also have projects maybe on how it has affect the technology, the teaching and learning, how we do image processing to help to diagnose COVID or not COVID. Okay, you can also do some variance modeling, contact tracing, hotspots, financial implication, mental health, health informatics. Okay, so those are some of the projects around COVID-19. I'm not going to tell the. Maybe I will go to two examples after this. Yeah. Okay. And then also the question of, can we predict the next COVID-19 variant? The answer is yes. Maybe some of you may have worked on some of the COVID-19 data. Okay, and one of the group is working on this. One of the PhD student is working on the COVID-19 variant prediction. And what are the economic impact on this? I already know. Okay, so now we look at the project that we do with in the oil and gas industry. Okay, so the title is a prototype. Prototype of intelligent data-driven predictive maintenance system. So what we do here for this project, we are given a data set for this machine that says it is to predict when the failure will occur. So that's what we have to do. So what the objective of the project is to develop machine failure prediction model using machine learning, and also to develop a dashboard prototype for OMG predictive maintenance monitoring. So there are two things. It is both, if you realize that these two are in the big data framework, okay? So the keyword here is prediction model, okay, and to use machine learning, okay. And then the second one is the dashboard. Dashboard is for what? Visualization, right? Okay. So to visualize what we do there is we have to provide the dashboard to monitor the predictive maintenance. Okay. So when we know how to predict whether the machine fail or not, okay, you want to visualize that on a dashboard. So that's what we have to do there. So the requirements here involve, okay, that's what I said there. We prepared data to support predictive analytics and visualization, and a machine failure model shall be created for enabling predictive maintenance and monitoring. And we will do the prototype for the so here I share with you what we do. Okay, so what we get from them is from the client, we have the data, the hourly reading. It's not all failure, you know. Okay, so the hourly reading and also the minutely reading of the machine. Okay, of the machine. So they have many sensors or predictors come with the data. I'm not sharing the whole data here. This is confidential. But to tell you, okay, what happens with the data, we do the data preparation, do the data cleaning, data appending, data categorization, okay, aggregation, integration, and prepare for and to merge the data set. So we prepare the hourly and minutely data, aggregate and merge failure report and reading data set. Okay. And then we do the exploratory data analysis. Okay, so you can do the plot there, scatter plot, and do the farm failure analysis, data trend, correlation analysis, k-means clustering, and also the data categorization analysis. Okay, and if you want to know more about the project, you can look at this paper. We have published the paper, Machine Learning and Synthetic Minority Oversampling Techniques for Imbalanced Data. So you see that the problem that we have from the data is imbalanced data of failure and non-failure. So we have 97% of the data are okay, and only 3% are failed data. So it is an imbalanced data. So we have to solve that data problem first before going to do some processing or to do the model. Okay. To do model and also to predict the machine failure. So that's one. We also have another paper. This is still under revision. The exploratory data analysis with visualization for uncovering produced water reinjection behavior. So, you know, now the name of the hardware or the machine is PWRI, produced water reinjection behavior. Is part of the process of in oil and gas. This machine will fail when there are things happening. So we have to find out what are the things that is highly correlate to the failure behavior. So we have to look at all those after we have the data. Okay, the next one is on the operational monitoring dashboard for, this is not gas platform, this is our first topic. Also using predictive analytics. What we do here, this is another part of the process. Okay, so this is the middle process in the, this is called bed absorption works. Okay. So what we have here is like 4 beds here. For example, A, B, C, D. They have to dry the gas. Okay, the gas comes in. They have water, so they have this bed to absorb the water. So we have to calculate the absorption and to see when the bed will fail. Okay, so the bed performance will decline in time. Okay, so the predictive analytics is to know when will they can change the bed. Okay, they want to know earlier so that it will not cause a disruption in the production process. Okay. So it is very, very important for them to identify or predict earlier so that, the process does go smoothly. Okay, supaya tak payah tutup the plant, kan?
Professor, you have 10 more minutes for finishing the presentation.
Okay, so going to the next one. Thank you. We have this project in the healthcare. This is the to identify which images are cancerous or not. Okay. So we use the histopathological breast cancer images, the BRICHIS dataset. So they have different types of, different magnification for the same image. For example, here is one from one person, but it is a 40 times magnification, 100 times, 200 times, 400 times. So, so we have to find out, okay, whether they are benign or malignant. So this also been published in diagnostics. Okay, so you can, if you want to know more, you can read the paper in diagnostics. They are freely available for you to download. you want. Okay, so with with that, I think I will end the lecture. So I will say this with another ayah from the Quran. Subhanallah wa bihamdi, adada khalqi wa rida nafsi wa zinata arshi wa midada kalimatihi. So this is a dhikr that you can read that will give you a lot of pahala for this. And the Prophet says read this 3 times in the morning and the afternoon. Okay, so what it means is glory and praise be to Allah as much as the number of His creation. Okay, so we don't know how many creation He has. As much as pleases Him, as much as the weight of His throne. We know how big is His throne, and we don't know the weight of it, and as much as the ink of His words. So with that, thank you very much. I open the question.
Okay, thank you very much for Professor Jasni for the interesting presentation. Now, I would like to open the discussion session. So for all the participants, if you have any questions, you can drop the question in the chat box, or if you want to ask directly to Prof. Jasni, you can raise hand icon in the Zoom. And I think there are already some questions from the participants. Prof. Jasni, I would like to help you to read the questions. First is from Anna. About the project, why does the method use k-means clustering even though the goal is to classify into group O and G? We don't use the classification method.
Which question? Anna. Oh, from Anna.
Yes.
Okay, so Anna says, okay, why does the method use k-means clustering even though the goal is to classify into groups O and G? Why not use classification method? Oh, okay. This one is the failure and non-failure, right? This one that use clustering k-means. Is it?
I think it's from your first paper that you present. The classification from into O and G.
Okay. For the paper, that one I'm not sure because I don't think why we use k-means at that time. Looking at all the variables, we want to look whether they will form clusters. But then after that we realize that we do not use that k-means all the way. Because I said it was the problem was the imbalanced data. So imbalanced data, right? So what we did, because we only have 3% of failure, a very low failure rate. Okay. So and here is a binary classification problem, right? Right? It is fail or not fail. Fail or not fail. So, and we have a minority class here that is the failure is only 3%. So what we did was using the SMORT algorithm, the synthetic minority oversampling techniques to increase the number of samples. So what we did was to try to balance the failure and the non-failure to up to 50-50. So we tried different percentage, like 30%, 40%, from because to start with we had 3%, right? So we try to make it 10%, 20 up to 50%. And what we found from that was that using SMORT with classifiers, SVM with RBF, they are the best to have the highest sensitivity when the data is balanced 50-50. So we also use knife-based and also logistic regression for that. And we have compared with that, and we found out that SMORT SVM is the best for this problem. Okay.
Okay. Thank you for the answer. Then move on to the next question by Siti Mahmuda. What is the difference of machine learning and statistic method in data mining?
Okay. Part of machine learning, you give the computer to learn of what the patterns are. So different with the statistical method. Okay. So you use the data to train your algorithm to understand the pattern more. So that is machine learning, right? So you can have some AI into that.
Okay. Then I think we can go to the next question by Mawanda, Prof. Chesney. So the question is, suppose that we want to teach data mining to people who don't code, then what is the best software that you suggest to us?
Okay. What do you want to do? What do you want to do with the data? And I will ask, you want to do data mining? Okay, so there are, if for you to use, for example, Python, you need to code, right? You have SAS. You can do also, what was that? You have also also you can do. It's also it is a coding. You need some coding to it, but you can do some box plots and things using R.
Yes.
And you have SAS and Microsoft Azure there.
Okay. So
For
actually there are
visualization, like I told you, you can use Tableau and also the Power BI. So they have quite a range of things that you can do in there. But the most important thing is to look at the data first. I mean, whatever you want to fit in the system or the tools, you need to know, you need to understand what is going on, what is it that you are going to do with the data. So it's not just the tool. I think the most important thing is what are the processes that involved in there. Looking at the data alone may not be able to solve the problem that you are going to take out from the data. It's not just, oh, okay, we have data. Okay, we fit in and put in link here and there, and and you should be able to get the answer.
So
Do
actually
I
it depends
answer
on
your
the-
question? I don't know.
So basically, it depends on the case itself. Yeah, Professor. Okay. Actually, there is one more question from one student. Okay, I will read the question about oversampling, Professor. Is the oversampling technique part of the part of the pipeline of process of imbalance dataset analysis? And when you did apply the oversampling part to data analysis?
So we have two, right? The oversampling and undersampling. So actually, I am not the right person to answer this question. Where is the question?
It's sent from the private chat actually.
It's not in the chat.
Not in the Zoom chat.
Oh,
It's from
okay.
the private chat.
Sorry, I don't know how to answer that question.
Mm-hmm. Maybe it's regarding to your first paper, because there you try to make the data to be balanced for performing the data analysis, and see, maybe try to understand is that the oversampling is one of the pipeline in the data analysis.
Yeah.
So the question is shown in the Zoom chat right now, Professor.
Okay. So the question is, how do I know when to use the oversampling method? Is it?
Yeah, when do you apply the oversampling part in data analysis?
Okay. So because we have the now we have the problem of imbalanced data. So I think there are three approaches, right, for us to handle the imbalanced data. So one is the resampling at data level and cost sensitive. So this is if we want to resample at data level, then we have to collect more data, right? So resampling method, okay, so such as undersampling or oversampling, which we aim to rebalance the majority and minority class, could be the better approach to handle this imbalanced data, because we can easily implement it, right? So because we have few simple random oversampling of the minority class. So for that we use the SMOTE method. Okay. So there are other common algorithms like bagging and boosting, like AdaBoost, XGBoost. You can also use all of these algorithms for imbalance and large data sets as well. Okay. Why we don't use random undersampling? Because the majority cases causes loss of data sample. So that's why we use oversampling, because oversampling duplicate the minority cases, but at the same time it can lead to the overfitting problem later. Okay. So I don't know whether that's answer your question or not, because okay.
Yes. I think that's answering the question already, Professor, because there are some options that we can use, and you prefer to use the oversampling rather than the others. Okay. Yeah, I think that's all for the discussion. We would like to thank to Prof. Jasni for giving the presentation, giving us the lecture. Very interesting material for today's guest lecture. Also, thank you for joining us with this session, Prof. Jasni. And for all the participants, please check the link that have been shared by the team for the attendance and to claim the certificate in the chat box. And if you miss some parts of the session, you can watch the replay of today's lecture in our YouTube channel, Departemen Statistika ITS. Okay. Also, I would like to thank to all the team that has been supporting this event until the end. And for all participants joining today's event, we wish to welcome you again in the next event from Department of Statistics ITS. Thank you very much. So I think we can end today international guest lecture. So can I close the session by counting 3, 2, 1? Okay, thank you everyone. Thank you for everyone. Let's close the session by 3, 2, 1.
Thanks for Prof. Jasni.
Thank you, Prof.
Thank you.
ITS Statistics Department, which is located in Surabaya. Institut Teknologi 10 November, or known as ITS. It was first established in 1978, which at the time was one of the areas of specialization in the mathematics department of the Faculty of Exact and Natural Sciences. Along with the changing time in 2020, it officially changed to the Department of Statistics, Faculty of Science and Data Analytics.
Departemen Statistika saat ini telah mempunyai 3 program studi. Program studi S1 Statistika, program studi S2 Statistika, dan program studi S3 Ilmu Statistik. Ketiga program studi tersebut semuanya telah terakreditasi A. Sejak tahun 2019, Departemen Statistika telah mempunyai program kelas internasional bagi program studi S1. Kelas ini disebut IUP atau International Undergraduate Program. Pada kelas internasional, mahasiswa akan diberikan keahlian dan pengetahuan statistika di berbagai bidang dalam kelas dengan pengantar bahasa Inggris dan fasilitas yang lengkap.
From year to year, Statistics Department graduates have worked in various fields. In the development of industry and technology, we have established cooperative relationships with the universities at home and abroad, as well as government agencies and private companies that have been established and will continue to be improved. As means of supporting our needs, until now we have 5 laboratories including that Laboratory Computational Statistics and Data Science, Laboratory Business and Industrial Statistics, Laboratory Social Statistics and Population Studies, Laboratory Health and Environmental Statistics, Laboratory Economics and Financial Data Analytics. We have other supporting facilities as below. It has classroom, reading room, trial room, toilets, gazebo, Sigma garden, basketball court, as well as public facilities such as malls and ITS Central Library.
Dan di Statistika ITS kita juga belajar tentang komputasi. Dan banyak banget hal yang bisa kalian pelajari di statistika di luar dari hitungan. Dan implementasinya di kehidupanku, aku jadi tahu gimana caranya mengolah data yang baik dan benar. Dan ini berguna banget di kehidupan sehari-hari untuk membantu kita mengambil sebuah keputusan.
Di Departemen Statistika, terdapat akademik dan non-akademik. Di akademik sendiri, aku mempelajari tentang pengantar metode statistika, analisis numerik, dan desain eksperimen. Sedangkan non-akademik, aku tergabung dalam staf himpunan statistika dan staf UKM Pramuka.
Kami berkomitmen menjadi lembaga pendidikan dan pengembangan statistika bertaraf internasional yang berkontribusi dalam ilmu pengetahuan dan teknologi, khususnya bidang komputasi dan sains data, ekonomi dan finansial, sosial dan kependudukan, lingkungan dan kesehatan, serta industri dan bisnis.